Okay, so for this one, we'll just go through and hit the problems that you have here and show you some of the basic ones. Now, the good thing is when you're going through some of these, you're going to see some of these questions, you're going to go, ooh, I can do that. Hey, I can do that. So we just got out of 7.6, which seemed like it was a lot because there was a lot of stuff there. And you got to realize that's everything from sections, well, even all the way back to chapter 6, all the way up through 7.5, all rolled together in one section. So the rest of these problems should not be as bad as what you think they are. So they'll look better than what we had before. All right, first question on the review. You've got 9y to the fourth over 27y to the fifth. And for this one, you're going to do it basically in two parts. You're going to do the numbers, 9 over 27, and then you're also at the same time going to do the variables. We have y to the fourth over y to the fifth. And do it basically as two separate problems and almost multiply together. All right, 9 over 27, that's a regular fraction. You can divide them both by 9. Make it 1 over 3. And with the exponents, this is where you subtract the two numbers. 5 and 4 is 1. Wherever the bigger exponent is, that's where your leftovers have to be. So if you subtract 5 and 4, there's 1y that's left over in the denominator. So for that one, we just need to extend this line out so it's like that. All right, number 2. This one asks you for the restrictions. Or I think it says find all excluded values. So find the restrictions or find the excluded values, whichever way it asks for it here. So we've got 3t, that's over 2t minus 6. And again, if it tells you to find the restrictions, find the excluded values for anything that's here, you don't care what's in the numerator. That's gone. Don't worry about it. It's just what you have in the denominator. You set that equal to 0. So 2t minus 6 equal to 0. Add 6 to both sides. T equal 3. And same thing we were talking about with the end of section 6. This was t to the first power. If it's the first power, you only need one answer. That's the one answer that we need. All right, number 3. Same thing. Still finding the excluded values. So let's go with w squared plus 14w plus 24. And same thing as the part on number 2 here. You don't really care about what's in the numerator. You're just going to exclude what you have in the denominator. And for this one, because you have w squared, you're looking for two answers, you've got to exclude. So for this one, you're finding the factors of positive 24, where the sum's going to equal positive 14. So, and again, it's all positive, so it makes it a little bit easier. 1 and 24, 2 and 12, and hopefully right there, that's when you go, wait, there we go, 2 and 12, because 2 plus 12 is 24. So when we find our excluded values, it's w plus 2, w plus 12, equal to 0, and if it's equal to 0, just got to change the signs. So w equal to negative 2, and w would equal negative 12. Okay, for example 4, problem number 4, they change gears just a little bit. Now we're not worried about restrictions. Now they give you a fraction and say, just simplify this thing. Again, no mention about anything in the directions in this one about excluded values or anything. So for this one, it just simply is simplify. So now you're just canceling. You've got a W plus 4 and a W plus 4. Cancel those out. You've also got a 2W plus 7 and a 2W plus 7. So you can cancel those out. So it leaves you with 48 over 8. When you simplify that, you do just get a plain old 6. Okay, number 5. Same directions. It's still simplify. Alright, so we start with 6W squared minus 8W over 2W squared minus 4W. Okay, so here's one where a little bit different of how it's set up if you just kind of worry about the top part. I'll bring that back out in just a second. Let me erase this for 1 second. If you take that part out, you've got 6W squared minus 8W. Again, the numerator and denominator are basically two separate problems. You have to factor the numerator as much as you can, then you factor the denominator as much as you can. So for this part of it, if you've got 6W squared and 8W, they both have a W, and they're both even numbers, right? So you can take out the W and you can take out a 2. So for that one, we'll do that. We'll take out a 2 and a W. So basically, we're just taking out the greatest common factor for this part. So 6 divided by 2 is 3. We take out one of the W's, there's 1 left over. 8 divided by 2 is 4. We took out the W that was there, so it's just 3W minus 4. And then the bottom part, same thing. They're both even. They both have a W, so take out a 2 and a W. And then tell me what you got left over. Well, 2 divided by 2 is 1. And we've got the W. 4 divided by 2 is 2. Took the W out. And now we're basically back to the same problem we had in 4. You cancel out anything that's common. Well, nothing here, but you've got a 2 here that you can cancel and a W here that you can cancel. So that's 3W minus 4 on the top, and W minus 2 on the bottom. And I think the hint they gave you on this one when they asked you to simplify was they said simplify, and in the directions it said use the greatest common factor. So they kind of, if you look at the objective part of that one, they gave you that hint that, okay, you're going to have to use the greatest common factor on this one. And whatever you see in the review when we're going through the sample test, it should be pretty much the same type of problem when you go through it on the main part of the test. Okay, one more, simplify. I have U minus 8 over U squared minus 64. Before you do anything at all in this one, again, you have to factor. So when you've got the U minus 8 on top, nothing you can do there. But the bottom is a difference of 2 perfect squares. So that's an U plus 8, U minus 8. And you can cancel this U minus 8 and this U minus 8. And again, the one thing to be careful of on this one is you do have a U plus 8 left, and sometimes people just put, oh, there's U plus 8, and it's good to go. But remember, when you cancel, you basically have to put a 1 there as a placeholder, so there is a 1 on top. So it has to be 1 over u plus 8. If you just put u plus 8, it's going to count wrong. So make sure you put that 1 over, because, again, that's in the denominator. It has to be in the denominator when you put that answer there. Okay, for number 7, it's almost the same problem, but they changed the directions on number 7 because it says to multiply. But from what we were saying earlier is that when it says to multiply, that's the third option you're going to do. The first thing you're going to do is you're going to factor. The second thing is you're going to cancel. The third thing is then you finally multiply anything that's left over from everything you had there. So we've got 3x plus 21 over 6x minus 5 times 3x minus 18 over x plus 7. Okay, so when I give you the directions here on these problems, even though it says multiply, you really, again, before you do that, you factor as much as you can, then you cancel everything that's left over. That's when you go back and multiply it all together. So if we factor 3x plus 21, you can divide them both by 3 and make it x plus 7. You've got 6x minus 5 on the bottom. Nothing you can do to factor that one, so it stays like it is. On the top part, 3x minus 18, you can divide them both by 3. Make it x minus 6. We've got the x plus 7. Okay, so there was the first thing. We multiplied everything as much as you can. Now that you've multiplied everything as much as you can, you've got a few things that will cancel out. You've got the x plus 7s. Now, here's the temptation again. That sometimes people go, oh, there's a 3 and 6. But remember, that's 6x minus 5. When you've got that x minus 5, that's stuck together. You cannot cancel that 3 and that 6 because technically the 6 goes with the x minus 5. So it's all there. Whatever you've got left over, that's what you multiply together. So on the top, you've got 3 times 3 on the outside. So that's 9 times x minus 6. On the bottom, you're left with that 6x minus 5. And since there's nothing else on the bottom, you don't have to put parentheses. That would be what you're looking for. All right, number 8. Same problem, or same directions. It still says to multiply. But again, that multiplying is really the last thing we're going to do. We're going to factor and cancel first. Okay, so factor, factor, factor. You're looking for the factors of 6 to get you to 5. And again, they're all positive, so if you factor that one off, the factors of 6 that would get you 5 would be 2 and 3. You've got time. Now, 4x minus 8, you can divide them both by 4. So divide both of them by 4 and make it 4 times x minus 2. Nothing you can do with the x plus 3. And for this one, it is the factors, and again, don't let the signs throw you off. When you're looking for the factors of positive 6. Because that one, there's 2 ways to get 5. You could do 6 minus 1 to get 5. You could do 2 plus 3 and get 5. So you have to, this is where the signs make all the difference. You're looking for the sum that's going to equal -5 when you do the bottom. So that means the negative has to go with the bigger number. And if you do a positive divided by negative, that means the other number also has to be a negative. So to get -5, we're going to have a -2 and a -3. Okay, so there was the first step. We factored everything as much as you possibly can, and once you factored it, now you're going to cancel. We've got an x plus 3 here and here. You've got an x minus 2 here and here, and that's all that's left over. So now you go back and multiply everything together that's left over. Well, that's 4 times x plus 2, and that's over x minus 3. And now somebody may be asking, do we have to multiply the 4 times the x plus 2? No, you don't have to. You can leave it just like that. If you multiplied it out and made it 4x plus 8, it should still be okay. They should take either answer on that part of it. Okay, number 9. Actually, the next two are pretty much the same way. It's division problems. And remember that division is the same thing as multiplication. So you're really not, the division is the last thing you're going to do. And technically, when we're dividing this one, we're only going to do one division. There's 2 that's in here. We're just going to do 1 for now. If you have 3x minus 9 over 9x squared minus 4 divided by 5x plus 7, and it's over 3x minus 2. That it's a division problem, but there's one thing we do to make it a multiplication problem. There you go. Keep change flip. And then once you make it a multiplication problem, you do it the same way as we did the other 2 problems of multiplication, that you're just going to have 3x minus 9, 9x squared minus 4, change the division to multiplication, and flip this thing upside down to put the 3x minus 2 here, and the 5x plus 7 there. And now that's a multiplication problem, we're going to do the exact same thing. We're going to factor it as much as we can, you're going to cancel it, and then once you've done that, then you multiply whatever's left over. Okay, for 3x minus 9, you can divide them both by 3. And make it x minus 3. 9x squared minus 4. Those are 2 perfect square numbers. So that one should be 3x plus 2. And 3x minus 2. And these 2, there's nothing you can do to factor those, so they'll stay just like they are. And not much cancels. Just the 3x minus 2. So that when you're finished, you've got the 3 and x minus 3. On the top, on the bottom, we've got a 3x plus 2 and a 5x plus 7.